great to have you. Thank you for answering my cold email and deciding to join us in this beautiful venue. So to get things started, you've done a bunch of things. You were also CTO at Twitter and ran the company for a while. So you've done these large systems before. Tell us, for the people that don't know, what are you up to today?
Well, first, thanks for having me. Thanks for the cold email. I'm building a company. It's called Parallel Web Systems. We've been at it about 2.5 years. We're building a collection of APIs that agents use to search and access the web. So if you think about any agent which is trying to do, a lot of our customers are frontier AI agent companies. The things their agents like to do, one of the core components ends up being giving the agent access to search and to read content on the web. And that's what we do.
Yeah, so a lot of us here today are essentially reinventing things that have already existed. And so we're all at least were, big Google search users, 10 blue links, all that stuff. And so why don't agents just use that? I've been asked this many times, it's just a sandbox. We have VMs, it's the same thing. So what is in your part of the infrastructure stack? Why is that so different?
Yeah, no, so there are two things to note. One, we started because of this belief that agents will actually do a lot more searches than humans ever have. So we think the problem is actually a 1,000 scale problem than what the current infrastructure is built for. And even the business models will change. So we got to 1,000x or more because the humans using Google is limited fundamentally by how much time people have online on a mobile device or on a computer. If agents are doing useful work, human attention, human time is no longer a limiting quantity. The limiting quantity for use of this infrastructure is how much value can be generated by basically using tokens or GPUs on top. Now, the product changes a lot relative to human search. On human search, you end up with this mental model of people in a browser. They will type queries which are short, incomplete. You will produce 10 blue links, and humans will go on a random walk across the web plus other searches in order to finish a session. That's the mental model. Baked in are a lot of idiosyncrasies of how humans work. We're typically patient up to a second, and then we get impatient and start losing people. So if a page loads slower than a second, it's terrible. If a search loads slower than a second, it's terrible. We're pretty bad at scrolling down within web pages. So if you're below the fold, you're kind of not relevant. So if you're Google and you're ranking a page and you have a question, let's say there is a really detailed, comprehensive, authoritative answer on page 7 on a page, say a PDF that someone might publish, versus someone who creates SEO-optimized content and puts a terrifyingly short and bad version of that above the fold on page 1. If you're Google, you have to rank this terrible thing. You just have to, because no one's going to find the useful content on page 7, and people will bounce. In an agent context, we get to change our APIs. The questions are no longer under specified keyword queries. They can be more descriptive, more details. Agents are pretty willing to tell our APIs exactly what they're looking for. We don't have to bring them 10 blue links and send them on this random walk. We can try our best to actually bring the content from these web pages straight into the agent's context window. We can give the agent additional tools which are agent-friendly, like they can grep over domains, they can grep over web pages, they can trigger crawls, and you can actually give them tools and powers that humans have never needed because we don't know how to use them.
I feel this is similar to most of the conversations I've had today, which is one, for Google search, you're capped by the number of humans in the world times the time of day that they have to be able to do the search, right? That's your cap, and that's your maximum. And so for agents, assuming that there are humans to the power of n agents, then there's no cap, essentially, depending on how much GPUs you have, but essentially, theoretically, there's no cap on that. So that's a scalability infrastructure problem. That's just one. But the other thing is that actually the interfaces and tools that the agent uses that you have to offer are quite different. Like we on sandboxes have one thing versus VMs, but you on search also, I hadn't thought about, like, can you grep over the results, right? Haven't thought about that, but obviously if you're doing that, that is some of the things. So are there more details you can share directionally about what you've built on that, or how, and also what I'm curious about is just like the scaling problem. How do you think about that as well?
Yeah. So scaling problem, I think we were talking backstage. It's kind of interesting, right? Like we will often see this massive spike of usage because someone kicked off a massive swarm of agent on a problem, and those things are just like hammering us. And they'll work for a few hours and then go away.
Yeah.
And I think they see this, we see this. These sort of the traffic patterns as they exist today for these sort of large-scale agents, it's kind of interesting. You can see the traffic pattern, which is human-triggered, which is like chatbots or human-in-the-loop agent traffic swarms, where a human is overseeing them, or even like human kicking off one background agent at a time.
Yeah.
But then you see these other patterns, which are, and we think about this as sort of the multiplier, which is like one human input to number of web searches that happen underneath. It could happen because someone says, okay, I have this big database, go do work for every row in the database. And so now that's like a big for loop of agents that are just running that got kicked off. Or you see things like, oh, I'm going to create a pretty sophisticated agent swarm to do 3 hours of work and burn a bunch of tokens and a bunch of web searches along the way. And then you see people setting up these crons, which are like, oh, every morning do all of these things for me, or every time I receive an email, do all of these things for me. And so this multiplier of like human input to number of amount of work that happens. And we get really excited when a high multiplier use case pops up, but the traffic patterns are very, 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 very different and still emerging. What I'm most excited about is, like you are, is more and more of the traffic pattern being sort of background agenty,
Yep.
or creating the perception of an always-on agent. So perhaps I have a question for you. Listen, one of the mental models you can carry is agent has a part of, it's trying to simulate a part of a human brain, which is reasoning. It's not doing a bunch of other things. Humans have always walked around like we've bought like phones, computers, we've gotten sort of virtual machines that we work with. And I think of sandboxes as the tool that we are creating for agents. And so if you can have a lot of agents, you can have a lot of sandboxes. We think of ourselves as like the APIs as the equivalent of a human alternatively would go into a browser on Google search and read through a bunch of pages. We build a collection of APIs to replace those. But if you think of compute abstractions, right, it's about how quickly can you access compute, how persistent is memory in there. So if you think of the difference between an EC2 and a Lambda, they're very different in terms of how you design for them. Are we going to see that same 2 or 3 patterns emerge as it relates to sandboxes?
Yeah, so, I mean, for the people that were here this morning, which is great, there was a part of the keynote which says we essentially think of sandboxes, to your point, as composable computers. Like, if you're a kid, when you were a kid, I assume you did, I did, like put together computers, and so it's like a CPU, memory, disk, a GPU, install an operating system, there you go. To do that, it takes, a few hours, but we need agents to get that in like, 60 milliseconds. So like we do that composability of them for the different use cases. So that is definitely part of that. But the other thing that we thought about is we essentially wanted to give it like an EC2, so it's long running, it's stateful, but you want the speed of a Lambda, right? And so the way most sandboxes originally started, they were just Lambdas. It's just like, I need it fast, and it was all ephemeral, it was just like, a code execution box. Yep. Type in Python code, get the outcome. But now that the agent actually has to work, it needs the computer, so that we had to figure out how to do that from a technical standpoint. And so there's a lot of things that we sort of like, these snapshots that are preloaded on underlining nodes so that you have that speed, but there's no reason that you have to sort of kill that, or you can essentially change the state inside of these machines like a VM. So there's a lot of the hard things we had to solve for that.
So, but are there no trade-offs between getting this sort of stateful persistence versus fast, cheap spin-ups? Are you saying you don't need to trade off, or you can compose one and form a continuum between the two?
The trade-off for the consumer does not exist. the trade-off on the cost is there. And that's why we have, and one note, we have a bunch of customers that have often lately, because of OpenClaw, said, oh, we need like a $5 sandbox a month. I'm like, we can't do that. Like we technically can't do that. I would love to give it to you, but I can't do that from a technical reason. So there's a cost penalty to that, a financial cost penalty.
Awesome. So our talk title was like the future of AWS. I know we had a conversation which inspired this.
Yeah,
so
our conversation was like at the beginning, so I'll ask you, since it's just you've turned the questions on me, so I'll turn it back on you. So the question as we start is like, what is the future of the AWS? Because like Russ from LiveKit, also like we're building the AWS for agents for voice. We say we're doing that, you guys are doing that. And so in your mind, what are the primitives of this like new quote unquote AWS for AI agents?
So we are not building the AWS. We're building one small service that we believe that most agents need. But in my mind, like if you think of building like an intelligent agent or an application which has a bunch of agents underneath, right? Like first thing you have to buy is like GPU inference models, whatever you want to call that. So you definitely need that. You need a lot of them are so good at writing code that like for most applications which are somewhat long running and not like immediate chat responses, I think you need some sort of a compute environment for this thing so it can do useful work and create artifacts. Which is where sandboxes come in. I think these agents have like partial world knowledge and create this perception of being both smart and all-knowing, which they aren't. And so you kind of need to meet user expectations, supplement them with a web search API and a lot of work. Even when you're not trying to do really web-intensive work. That's the implicit expectation of what they should be able to do. And I think then you need to roughly give them access to a lot of your private data. And I think these are the core things that are in the, let's call it the compute loop. Now there's a bunch of stuff on the control plane, which is like authorization, authentication, observability, and whatnot. And I think the big open question, at least where I don't know if I feel that there's a settled answer, is that like, how do you give it memory? Is that all within the sandbox? Is that a separate thing? How do you think about like self-improvement loops and does every component have to be self-improving, or is there like a separate way of driving those? But I think this is sort of what's emerging in my mind is the rebundling of infrastructure for a dominant access pattern, which is very agent-centric.
Yeah, when I think about that, and when you start using multiple agents in your personal life, you start like figuring out, oh, I actually would be great if I could use memory and like knowledge from one that's running one task to pass to another. And I think that a lot of things there are still not solved. And so we will, I believe, see these new infrastructure primitives built out because no one thought they needed a search, no one thought they needed a sandbox, and it'll be more there. What are you guys at Parallel? Because you guys are doing more than one thing. Like, what are you doing outside of the search, or is it just the search? And how do you think about like expansion there?
Yeah, so we, at its core, all of our products are APIs. We build all of these APIs that are meant to be used by agents and people building agents. Within that box, though, I think there is a lot to do. So one of the obvious things you do is search that we've spoken about. There is a large amount of value in my mind in doing search agents. In fact, like a lot of our customers use our search agent APIs, which bundle search and a bunch of heavily optimized query processing plus LLMs on it.
Okay.
If you have to think about it, they are just like specialized agents to do web work. So and it's obvious how you can really differentiate there, because if you build a general purpose agent which doesn't know distributional properties of web work, which is optimized for using every kind of search tool and mostly for writing code, those things end up not doing that well when given a pure web search or deep research problem. So we optimize those. Now the thing we're most excited about going forward is actually converting the web for these long-running agents from pull to push. So one of our APIs that is relatively new and sort of barely works is the monitor API.
Okay.
It's meant for you telling our API, or you as in like your agent telling our API, saying, call me when X happens. And you can define X to be pretty high level or abstract, which includes a large amount of reasoning underneath. And what will happen is we're constantly crawling the web, a very, very large scale crawl. We're going to do some very basic compute on top of every time we notice something on the web changes and try to figure out, does this merit a call to you so that you can run your agent? And so if you think about like running a regular collection of keyword searches and like, do they pop? That's about 12 or so orders of magnitude less compute than running a GPT-5 scale model on a piece of text, right? And so if you think about like the various things you can implement along the way to know when to trigger your agent based on some stimulus in the world, that's really, really compelling, really, really exciting, and starting to work.
Tell me about like how often you guys then crawl the web, because if you're a push, so I'm making this up, like I'm a hedge fund, which I'm not, I don't know anything about it, so don't hate on me if I'm wrong, but in the sense of like, if something happens somewhere and the price of commodities should change, I want to know that in real time. So like how, that seems very, like the web is big and it's much bigger.
No, great question. So I think if you're thinking millisecond, second latencies, I think our solutions, and this architecture is in the architecture is much more data feed centric. If you're thinking minutes, hours, days, our architecture is the one that wins. And the broader, more abstract thing is definitely possible in hours. So if you think about how this all works, right? Like we have this massive crawl, and the way a crawler works is you have a crawl frontier, every link that I've ever discovered plus crawled so far. And you discover a lot more links than you crawl. And for things you've crawled, you're trying to figure out, okay, when should I recrawl them because they might have changed? Should I recrawl them to discover new URLs? And you're constantly discovering new URLs. So the big problem there is, how do you prioritize your crawl?
Exactly, how do you prioritize? There's so much there, right?
Right. So we have models which prioritize the crawl. And in addition, they can be informed by things you're most interested in. So if you showed up and you said, and you're a bank, you're not, but if a bank showed up and said, listen, I've given out credit to these small businesses, I need to monitor them for bankruptcy risk, and here are my 300 signals for the 1,000 small businesses I've given credit to. These are 300 things I need to know within hours or days if their credit worthiness materially changes based on these signals which might be on the web. So call me if any of these things happen, right?
Got it.
That's roughly what people come to us and say. What that'll do is we will crawl data about these businesses, whether it's on their domains or anywhere on the web, way more frequently. And you can kind of predict from often a URL or its inlinks or the bits and pieces you know about it, about what it's likely to contain, and you can build models for that. And so now you can have a high crawl frequency on certain subsections of the web that are of more interest, and we'll let our customers' queries inform where we should focus that compute and that effort.
That's interesting, which is different, I would say, than most of the infra players, including us, where most of us are like we serve agents, but we don't actually run agents or AI in our infrastructure, where you guys actually have that as a key component.
Yes, and I think in part, right, like the part of the reason our search products are so differentiated is because we run one of the largest customers of those APIs ourselves. And there is a very rapid iteration loop. In fact, like the first time we shipped our search API was the third version of that abstraction that we built internally to build our own agents. And I think that tight feedback loop, being your own sort of biggest, most demanding customer, actually lets you build better products.
Of course. I mean, every time, it's interesting for us, I don't know if you had this experience, is that as we grew, I don't have a chart here, but our sandboxes, like it was going like this, and then it grew, and then it went, and then it grew again, and then now we zoom out, you can't even see that. Every one of those super huge spikes, unfortunately for our customers, some of you experienced this, is something broke, like, and then you had to make it better. But it wasn't the thing you expected. It was always something arbitrary. Did you have any experiences like that as well?
Yeah, so the first version of our API we're building this our search API, and we initially didn't internalize that fine-grained tool access. Like we were trying to bundle a lot of tools into our search API. Be like, okay, you don't need a fetch API because why should you? Humans do the random walk on the web. One API to rule them all was our initial instinct, right? Turns out that empirically we could never make it stick. under the constraints that happen. And we had to create an extract API, which is essentially the API that allows the agent more agency, right? So you often imagine and architect a system a certain way, and then the empirical reality, a lot of the agent world and model world is like empirics rather than design. You have to run a lot of empirical testing and iterations to know what works. And I think then I remain flexible in that, like maybe in 6 months or 9 months, some of the lessons we're learning empirically today might look different.
Exactly. And before I let you go, because we're out of time, it's interesting, and also, and I keep talking to especially speakers here, we're all suffering the same problems, all learning this all live. So hopefully we'll get to chat about this again. Thank you so much, Parag. Thank you so much, everyone. It was great to chat.
Thank you all.